The remainder theorem says that let p of x be any polynomial of degree greater than or equal to 1. That means it cannot be a constant, okay? Because constants have a degree of 0. And let a be any real number. So let a be any real number, okay? Then if p of x is to be divided by a linear polynomial x minus a, okay, then we will get the remainder by finding p of a. Why p of a? Let's understand that. So p of x is a polynomial and it is to be divided by a linear polynomial x minus a. You can see x has a degree of 1. Then we get the remainder by finding p of a. That means putting a here in place of x. Why a? Because a is the 0 of the divisor. What is the 0 of x minus a? It is a positive a. That's why when we put here p of a, we should get the remainder. Now we need to prove that we will get the remainder when we put a here. Okay, that's what we need to prove in this theorem. So let's prove it. Now to put a here, we first need p of x. We need this polynomial. What is p of x? It's not given to us. But we know the relationship between p of x and the divisor and the quotient and the remainder. So let p of x be any polynomial with degree greater than or equal to 1. That's the dividend. And suppose that when p of x is divided by x minus a, which is the divisor, the quotient is q of x and the remainder is r of x, then we get this as according to the division algorithm, that dividend is equal to divisor into quotient plus the remainder. So this is our divisor, which is a linear polynomial, into the quotient plus the remainder. Now let's look at what will be the remainder here in this case, since we know that the divisor is a linear polynomial. So what will be the remainder? Since our divisor is a linear polynomial with a degree of 1, we know that the degree of the remainder will be less than the degree of the divisor. Since this is 1, the remainder can only have 0 as its degree. So since the degree of x minus a is 1, the degree of the remainder is less than the degree of x minus a, then we know that the degree of the remainder has to be 0. And if the degree is 0, then the remainder is a constant. This means that r of x is a constant polynomial. Let us say that it's r. Let's take constant as r, and the variable will have a degree of 0 with it. And so if anything has a degree of 0, it will become 1. So x raised to 0 will always be 1, and r will always remain r into 1 r. Okay, so for every value of x, we will have r of x as r. And therefore, we can say that putting r in place of r of x in the division algorithm, we can say that p of x is x minus a, which is the divisor, into q of x, which is the quotient, plus r, because r of x is always going to be r x raised to 0. So it is always going to be r, that is r. So in place of r of x, I'm going to put r. According to the theorem now, if p of x is divided by a linear polynomial x minus a, then the remainder should be p of a. So putting the 0 of this polynomial, which is a, by putting it in place of x. And let's now put it. So we have this p of x is x minus a into q of x plus r. Let's put a in place of x. So p of a will become, here I'm going to put a minus a into q of x plus r. R is a constant now. and therefore a minus a becomes 0, so this will turn 0. 0 into q of x will become 0 plus r, which will be a constant r. So hence we have proved that by taking the 0 of the divisor and putting it in place of x, we can get the remainder, which will be a constant because we are dividing it by a linear polynomial. Okay. So let us solve this example using the remainder theorem now. So this is done in a long division method, and you can see that the quotient that we get is 3x minus 1 and the remainder is 1. So let us see if I put the 0 of the divisor into the dividend, whether I get the remainder or not. So what is the 0 of the divisor here? Since the divisor is x plus 1, the 0 of the divisor is minus 1. And now I'm going to put the value of minus 1 into this dividend. So substituting x by minus 1 here, we get p of x as p of minus 1 as 3 into minus 1 square plus minus 1 minus 1. And then if we solve it, we get 3 into minus 1 square is 3, plus into minus becomes minus, so minus 1 and minus 1, which will become 3 minus 2, and which is 1. So you can see you get the remainder, the same remainder as you get it in long division method. So that's how we use the remainder theorem to find the remainder.